Okay, so the sixth lesson is about data communication and networking, right? So here we are going to talk about how a particular network is arranged and what to be learned regarding the data communication part. So actually, in the first part of the lesson, we are talking about the data communication. Then we slowly move into the networks, how a network is created and how the data communication inside a network is happening, right? So as the very first thing inside this lesson, we are talking about the components of the data communication, right? So let me illustrate it to you and then you will realize how the things are going to happen during a data communication, right? Okay, now when it comes to the when it comes to any kind of communication, we always have something called. Let me hold on a second. Okay, so in any kind of data communication, it doesn't matter whether we are communicating data or not. In any kind of communication, we always find a particular device or a person who is staying as a sender, right? Since we are talking about the data communication, I'll consider a particular PC, right? And we have at the other end, we have someone who is receiving it. So we call them the receiver, right? So from the sender to the receiver, what they are doing is they are sending a message, right? So, or sending some particular data, right? So this data, or in common terms, we call it the message, is sent, right? And to send the data from one computer to another, or like from one device to another, we need something called medium, right? So when it comes to the medium, this divides into two parts. Hold on a second, people. Yeah. Some places they say medium and some places they refer it as media. Yeah, transmission media. Yeah, hold on. Let me confirm like with what word that you need to go through. Yeah, let's have both the words so it won't be a problem. Right. So we have guided media. Guided media means wired media. Right. And we have unguided media. That means wireless. Right. So regarding the guided media, there are three types of guided media that we are talking about. We call it the twisted pair and coaxial and fiber optics. So those are the wired media that we are going to talk about. Regarding the unguided media, we talking about electromagnetic waves. In simple terms, we say the radio waves. And the microwaves. And we use infrared and then we are going to talk about the laser communication using light, right? So generally, this is going to be the picture. There is one another component which we can't see in this communication. Like we can see the sender, we can see the receiver, we can see the data, we can, in most of the times, we can see the medium, right? So like either the medium or the device which provide us the medium, right? So apart from these things, these four things, there is another one called protocols, right? So protocols will be there regarding the communication, or like protocols define set of rules during the communication. Right, so that is something that is considered as the fifth element of the communication. So to fulfill a communication, you need a sender, you need a receiver, you need a message, you need a medium, and you need a protocol, right? So I'll mark them. So this is one, this is two, and message is the third one, medium is the fourth one, and protocol is the fifth one. Okay. So yeah, I want you to draw this small diagram in your book, right? So it will be a summarize or like a kind of a short note regarding the things that we need to talk about in the subject matters of the tune, right? So please copy it down. There will be some these kind of small diagramming parts or like summarizing part. So it's better you take it down when the exams are here. These things will be help you to do the things, right? So you can have the heading, network and data communication, or like data communication and network. There you go. Yeah, and people, is it clear about this particular diagram? Yes, everyone? Right, great. Okay. ඔව් දුලි නැනපෙත ක්ලාස් එක තියෙන පුතේ 3ට තමයි. ඔව් බ්‍රහස්පතින්දා 3ට ෆිසිකල් පටන් ගත්තම 3:30 5:30 කියන ටයිම් එකේ. Okay, one is done. How about others? Okay, anyone who is still writing? Okay, Sachintani, carry on, no problem. All right, so anyone else who is still writing? Okay, so moving forward. So that is the story regarding the very first page, people. So in the first page, they are just talking about what are these things. And then we are going to talk about the signal types, right? So there are two types of signals. Now, since we are like talking about data communication, hereafter we are going to talk about the things which needed to do the data communication, right? So the first thing that we need is a signal, right? So we are sending a particular message from one particular device to another particular device as a signal, right? So there are two types of signals, right, which we call analog and the digital. So the analog signal, we define it, it is any continuous signal for which the time varying feature of the signal is representation of some other time varying quantity. That means like you are going to talk about the analog signal in the terms of amplitude, sometimes the wavelength, sometimes the frequency, kind of things. So generally, we are going to show the analog signal in this particular manner. I think you are familiar with this when you are doing the grade 10, 11 science. They are talking about these analog signals and the qualities of those, right? And this is just a recap of it, right? So remember, analog signals are generated from the things like light, sound, right? Kind of things, right? So its nature is this, it's a continuous signal, and the values of the signal is continuously changing along the time. And we generally say this is a sine, this is kind of a sine wave, right? But in data communication, you don't need to like look into these things not in a scientific manner, but in a communication manner, or like the computing manner, right? But anyhow, you need to know the qualities of these analog signals, right? So analog signal, that's the nature of it. And later we are going to talk about the characteristics of these. So for the moment, I just want you to like have the idea about the shape of an analog signal. So the next one is a digital signal. These signals are generated by the digital devices, right? So unlike the analog signal, digital device, which generates the digital signals, generating those signals to have two specific states. Those states are considered as the zeroth state and the first state, right? So zero indicates by like this. This is the 0 point, right? So this is the 0th point, and this is considered as the 0.1. And unlike the analog signal, this is not gradually changing, right? So in the analog signal, it gradually changes, right? With the time, it gradually increases its height and gradually decrease its height, right? So is doing a class, so it's getting disturbed. Right. Sorry for that horn, people. So, yeah, like I said, the analog signal, it has the nature of changing its values gradually. So it increases gradually, it decreases up to some particular point, then it increases gradually. So that's how the analog signal works, right? But when it comes to the digital signal, there is no gradual increment or gradual decrement. It's just instant increment and decrement, right? So like for a specific, or like for a, if you consider a one particular point of the time, it indicates either a 0 or a 1. There is nothing in between 0 and 1 when you consider a digital signal, right? So zeros and ones. So now we are going to learn the qualities of an analog wave, right? So the first quality is talking about is the amplitude. So amplitude is considered as the height of the wave, right? So height defines, yeah, so we have to find the batteries, right? I'll put some batteries, then you can work with it. Right, after the class, I'll bring you some batteries. So the height of the length, the height of the wave is defined like comparing to the 0th axis, or like the comparing to the x-axis over here, right? So this is what you call the x-axis or the time axis, right? Comparing to this, they are talking about the height of a wave, right? So you can see there are different heights, right? Different heights are here. So a wave with a smaller height is called a low amplitude, and a wave with a higher height is called high amplitude one. So in between, we can say medium amplitude one, and it's a comparative one, right? So when you have three waves, then you can categorize those into a low amplitude, medium amplitude, and high amplitude ones, right? Like just by looking into a one particular wave, you can't say whether it is a low or high or medium if there is no any criteria to be considered, right? So when you got three things, then you can compare what is low, what is medium, and what is high, right? Anyway, the amplitude defines the height from the time axis to the highest point of the wave, right? So then we are going to consider about the frequency, right? So the frequency defines number of curves that you can see for a given amount of time, right? Usually we are considering a time period of 1 second. So that means here, if we assume the t's value is 0, here t's value can be considered as 1. So this is just, if you think if this is a 1 second of time, you can see this is having smaller amount of curves, or like number of curves are limited. Curve means from here to here, people. This is what you call a curve. This is what you call a curve, right? So number of these kind of curves will define whether it is a high frequency wave or a low frequency wave, right? So higher frequency means you can find more curves within a 1 second. Low frequency means you can find less number of curves within a 1 second. So, and there is another quality that they have introduced here, which is called the wavelength, right? Wavelength is defined by the distance in between similar kind of points, or like similar kind of places of a wave, right? So if you think about the similar positions or the identical positions, this one and this one creates identical positions. So this length is equal to this length, right? If you take this point and this point, identical positions, wavelength. If you consider this and this, again, identical positions. So which we call the wavelength. So wavelength is a secondary thing to be taught under the frequency. Like frequency defines how many number of curves are there within a 1 second. So greater the curves, greater the frequency. Lower the curves, lower the frequency. All right, people, is it clear up to this point? Okay. Right, great. Then we are moving to the next quality, which is called the pace. Now, pace, you should be understanding it very carefully. Now, pace means the angle of the wave comparing to the x-axis, right? So this is how we are going to think about the pace, right? If you think about the red wave, the red color wave, the pace is going to be, the angle is going to be like this. So we take the angle in anti-clockwise manner, right? So this is the angle of the wave to the x-axis. And if you think about this, this is going to be the angle. And if you think about this, this is going to be the angle, right? So as it says, space describes the position of the waveform relative to the time zero, right? Okay, so those are the ways, those are the things that we can understand as the qualities of a signal. So three major qualities: amplitude, the pace, and the frequency, right? And there are some other qualities as well, like wavelength, that we are talking. So the wavelength will be considered for the next topic in ours, which we are going to describe the propagation speed in a particular medium for an analog wave. So this is something familiar for you. In grade 11, you are supposed to learn a particular equation called what? V equals F lambda, right? And we are going to describe it over here as well. V is going to be the propagation speed, right? F indicates the frequency. This measured by hertz. And lambda indicates the wavelength. This indicates by meter, the M. Right, so the relationship in between the frequency and the wavelength is described like this. When frequency is multiplied by the wavelength, it gives you the speed of the wavelength. I'm sorry, of the wave, right? And when it comes to the speed, the unit that is being measured is by meters per second, right? So meters per second. How per second is coming? Because hertz can be considered as per second as well. ළමයි මට තප්පරයක් දෙන්න. Right. So people, as I told you, frequency measured by the hertz and wavelength measured by the meters and velocity or the speed measured by ms minus 1. So you need to know how to work with this V equal F lambda, right? Okay, is it clear, people? All right. Okay, now that brings me to do some questions with you regarding this equation, right? So let's try these questions. So you can have the idea in which kind of questions that you can take when you are going through with this particular equation, right? So I'm going to write the question over here, people. So you can write it down with me and you can give it a try. So question number 1. Okay, give it a try. Always write the units, people. That is what is important here. Yes, Nikini, what should be the unit? Unit's going to be the ms minus 1 dual, meters per second. Yes, Sachintani, that is correct. Yeah, Lalindi should come up with a unit dual. It should be meters per second, right? Dole, it's going to be ms minus 1, right? Right, so let me quickly do this for you. So this is what? Lambda equals 50 meters. F equals what? 10 hertz. So it's V equals F lambda. So that means 50 meters into 10 hertz. So it's 500 ms minus 1. Right, S is a capital one, people over there. M is simple, S is capital, so should be something like this. Why S minus 1 is there? Hertz equal to S minus 1. Right? Okay. So that's simple, right? And let's see whether this one will be able to figure out by you. Here's the question number 2. Right. Give it a try. I'm adding some more words over here. Find the frequency of the wave in hertz. Okay, Sachin Thani. Is it 2 hertz? No. Sachin Thani, පොඩ්ඩක් go through කරන්න calculation එක පොඩ්ඩක් එහම හැවෙලා. Nalindi, answer is correct. Netme, answer is correct. So how we are going to do this? Yes, Duli, that is correct. Now here they have given, what are the details they have given? They have given the V, right? V is given, so it's 500 kilometers per second. And the wavelength, the lambda is given. So 25 kilometers. So then we are going to apply V equals F lambda. We are supposed to find the F. So F is going to be V divided by lambda. So V is 500 kilometers per second. Lambda is 25 kilometers, right? So there are 125, there are 20 over here. And you can cut down the units as well, people, like kilometers per kilometers. So you are left with 20 per seconds. That means 20 hertz. Okay, is that clear, everyone? If you got any mistakes, please go through and do the corrections. Then I'm going to give you the third one. Okay, I'll put the third one over here. Now be careful when you are doing this. It has some conversions. Conversions means like you're going to try, like going to have a game with the hours, minutes, and seconds, right? So here comes the question. Okay, give it a try. Let me okay, let me do the calculation and see. Let me hold on. is, wait, Lama, give me a second. Give me a second. Okay, sorry for that, people. So yes, right, okay, right, okay. I've got something, some different answer. Let me illustrate it to you. So what do we have here is like V is given, which is 50 kilometers per hour, and lambda is given 300 kilometers. So we are asked to find the F, right? So we apply V equals F lambda. So F equals V divided by lambda. So V is 50 kilometers per hour. And lambda is 300 kilometers, right? So we can easily cut down these things, right? 5 and 6. And we can cut down kilometers per kilometers as well. So this gives you 1/6 per hour, people, right? So what would be the final one? Or like the, if I'm going to find this per second, how it's going to be? Is it multiplied by 3600? So it's going to be like in the 1/6 h minus 1. That means it comes over here, hours. So if we are converting hours into the seconds, what are we going to do? We need to multiply by 3600, that's correct. But since the h minus 1 over here, we are going to do it like this. 1/6. This is the place we are going to put 3600. Right? So it's kind of huge. People, are you getting this? Right? So it's going to be a very small value. You don't need to go through the smaller part. Right? You can say like 1/2 zeros will be here. 6 into 6 is 36. 3 is remaining. 6 into 3 is 18. 18 plus 3 is 21. So this is going to be s minus 1, which is 1/21,600 hertz. Right? So you can be certain about this if you convert these things into the things that you want. Now, if we want to convert kilometers per hour into ms minus 1 meters per second, what we are going to do is we are going to multiply 50 by 1000. So kilometers will be converted into meters. Divide by 3600. Then it will be meters per second, right? So if you do this, these things can be cut down. So it's like 500/36 meters per second, right? So if I take out the 300 kilometers into the meters, I just need to multiply it by 1000. So it's going to be 300,000 kilometers. I'm sorry, not kilometers, meters. So now I got the things from ms minus 1 and meters. So if I need to find the frequency, I'm going to divide what? The speed is going to be 500 divided by 36, and yeah, the lambda is going to be divided by 300,000. Right? So divide by 300,000 means 500 divided by 36 multiplied by 1/300,000. right? Like divided by 300,000 means multiplied by 1 over 300,000, right? So I'm going to take out these things. So it's going to give me the same answer. 5 is 1. Here I'm going to have 600. So here 600 into 36. So it's going to give me the same answer. 1 over 21,600. People, is that clear? Like I had something else when I was giving the math, but I messed up by taking out the like if I could give something smaller to the wavelength, it would be a nice answer. But yeah, I missed that thing. People, is it clear? Right, it's the same calculation that I have done in 2 ways. Right? Okay, so please do the amendments. And here I put the unit. Let me know when you are done, people. Okay. Right, one is done. How about others? Right. Okay, so let's move forward. Right, so it won't be this complex when it comes to your things, people. Like, so far we haven't received anything from this V equal F lambda thing, because this was added to the syllabus by 2019 for the 2019 examination. So far we haven't received anything, any particular question regarding this. So if it comes to be, it's going to be a MCQ kind of a one, right? So will be a very fine one, whether you can figure it out. Right, so I'm moving forward. Here I'm going to talk about the transmission mediums, or like the medias, right? So earlier I told you there are three types of, generally majorly two types of the guided and the unguided. Under the guided media, there are three types of wires that we have to learn. So one is called the twisted pair, other one is called the coaxial, and the other one is called the fiber optics, right? So twisted pair is the normal network cable that we see day to day in our day-to-day life. Like if you got a pure TV connection or a dial-up TV connection, you can see a network cable with that particular connection, a yellow color or a blue color one, right? Which has a where they have fixed into a RJ45 port, right? As well as a jack of RJ45. It's going to fix it RJ45 port, right? So the wire that they use is called twisted pair. It is because the nature of that wire, like nature of that cable, the inside, it has couple of wires which are being twisted, right? Actually, they got 5 couples which are being twisted. So altogether 10 wires are there. So 5 couples, they are twisted with each other. That's why it is called twisted pairs, right? And these twisted pair wires, they have 2 types of twisted pairs. One is called unshielded twisted pair wires, which we call UTP. And the other one is called the shielded twisted pair, which is called STP. So you can see the difference in between unshielded and the shielded one. Unshielded one is just having the pairs and the jacket. Jacket means the rubber coat, which is at the outside, which covers the wires, right? What we can see generally when we see a network cable. When it comes to the shielded twisted pairs, what they have done is they have sent a particular wire harness, or like it's kind of a very tiny copper wire harness as a shield around each and every pair. So that shielded twisted pair gives you much clearer transmission comparing to the unshielded twisted pair. And again, when it comes to the cost, the UTP, unshielded twisted pair, is low in cost, and comparatively, the shielded twisted pair is expensive, right? So those are the, that is a one kind of guided media that we have to learn. And this UTP and STP, or like the twisted pair kinds, are considered to be comparatively the lowest, comparatively they have the lowest price in the industry, right? So like comparing to the UTP, STP is expensive, but comparing to the other 2 cables, which is the coaxial and the fiber optics, these are low in price, right? So the second cable is called the coaxial cable, right? So this has a very thick copper line at the middle of the cable, right? Which we consider as the center conductor, right? And around that center conductor, it got an insulator, right? So that means whatever the charge in that which goes over here will not penetrate through this, right? So this is the insulator. And around the insulator, there is there is a shield which made out of copper harness, right? And surrounding that, they have the cable coat, or we call it the jacket, right? Which we can see when we see the wire, right? These kind of coaxial cables are highly used for the as the antenna cables. Not like the people who do not have pure TV and dialog TV. Even myself, in my childhood, we were having an antenna, and the cable which is coming from the antenna is connected to the television. Then only we will be able to see the television, right? With some interference and all these things, right? They are heavily used, this type of coaxial cable, to have the antenna connection, TV antenna connection. As well as nowadays, they are heavily using this for the CCTV connections, right? So from the CCTV camera to the set-top box, which is in their central point, they connect the CCTV and the central box using this coaxial cable, right? And it is durable than the twisted pair, as well as it is expensive than the twisted pair. As well as this can communicate into a greater distance comparing to the twisted pair, right? The twisted pair cables, they consider to be they use for the communications like 100 meters kind of a distance, and this can be used to communicate further than that. And when it comes to the optical fiber, this is the most expensive one, right? And again, it gives you the highest speed of data communication, or the fastest data communication. The reason is, inside the cable, it uses the light to communicate the data, right? So this is the surface that they use to communicate the data through the light. It is a very thin glass tube that they have. So when the light comes, it will reflect inside that glass tube and will communicate like this, right? And covering that glass tube, they got a cladding which is made out of plaster of Paris, and then covering that, they got a particular very thick jacket, right, which is made out of plastic. So unlike the twisted pair and the coaxial, these cables need to be carefully handled, right? You can't do the bending as you want. You can't do the steep bending as well. If it's so, this glass tube is going to be destroyed. Oh, it will break from some particular point. Then you won't be able to communicate, right? And as well as these fiber optics has three type of transmission modes, which is called the step index, grade index, and single mode, right? So the first one, step index, means this particular one, right? So the grade index, that is the second one, and the last one is the single mode, right? So you can see the different step index. They use the reflection, it's a kind of a sharp reflection that they are using. Here, very smooth reflection that they are using. It can be changed with the materials that we are using to create the glass tube. And this, of course, a straight line. And with the single mode, we won't be able to communicate for a greater distance because it is a single mode, right? So light is going, since the light is going inside this particular wire, it should be a straight line. Api science world light is not going in a curvy manner. Curve reflect. Otherwise, it should have a straight line, right? So these type of things are there regarding the fiber optics, right? So let me show you some real world pictures of these things, right? I really don't remember whether I have shown these things to you when we are like talking on the very first lesson. But anyway, I will show this to you. Yeah. Now, these are the wires that we have talked about: coaxial, twisted pair, and fiber optics. You can see the particular jack that they are using, right? This is what you call RJ45. This is kind of a different one, which we use to connect the fiber optics. And here, this is the jack we use with the coaxial cable. So this coaxial cable need to be like fixed and we straight away fix to the port. So it has locks around here as well as this. So they locked into that socket automatically. And yeah, this is the inner picture of the coaxial twisted pair and the fiber optics, right? So you can see how the things are happening over here, right? So yeah, that's all. Okay, so I think you had a good idea about how the media is working over here, right? So that is regarding the guided media. And this is regarding the unguided media, right? So first of all, we are talking about the radio transmission. That means we are going to talk about the electromagnetic waves, right? So this picture describes how we are going to hear something which is being broadcasted by the particular radio station or a TV station, right? In this case, it's a radio, right? So the presenter or the person who is conducting the program is talking to the microphone, and through the microphone, it's broadcast to the transmitter to the transmitter. So from the transmitter, using this electromagnetic wave, it will be broadcast to the to a greater distance, right? And in our devices, we got something called antenna. That antenna is capable of capturing this particular radio waves. But for antenna to be captured, this particular radio waves, we have to tune it up, right? Because these radio waves have different kinds of frequencies. You will see at the next page. So each and every frequency Like antenna cannot like take in all the signals, all the frequencies that it can quote. We have to tell to antenna, take these frequencies, waves into the device, right? ඒක තමයි අපි ඔය tune කරනවා කියලා කියන්නේ. දැන් අපි FM radios යනකොට they always market about their frequency, 99.9, 96.7, likewise. They always market about their frequency. So once we tune our radio to that frequency, then only we will be able to hear that particular program which is airing through the broadcasting station, right? So tuning means we are informing the antenna for which kind of a frequency that you are going to quote up. Okay, thereafter, what we are going to talk is the microwave. Before the microwaves, I have given some examples where they have used the radio waves, and there are many different kinds of radio waves in many different kinds of ranges. In day-to-day life, we use this VHF and UHF, right? So VHF and UHF is there to provide a particular message or a particular data in between these frequencies, right? So VLF, very low frequency, 3 to 30 kilohertz. So the frequency that we use, VHF, very high frequency, that is from 30 to 300 megahertz, right? And we are using UHF as well, ultra high frequency. Again, it is for 300 megahertz to 3 gigahertz, right? So that is what is there with the radio transmission, right? And the radio transmission, now this particular wave is given the name radio waves. It is because it was used primarily to do the radio transmission. That is why. Right? And nowadays, they are used for many different things. For the radio transmission, for the television transmission, even for the mobile communications, right? For GPS, for Wi-Fi, for Bluetooth, for walkie-talkie communication, everything is dependent on the radio waves, right? You can understand how important it is, right? When we hear the word Wi-Fi, so we know how important it is, right? So then the microwaves. Now, like comparing to the radio waves, microwaves are highly like more stronger than the radio waves, right? So we use radio waves to do the communication from one particular geographical point to another particular geographical point that is kind of terrestrial, right? But microwaves are generally used to communicate with the satellites, where they place at the space. So it is a much greater distance. And again, if you want to use that, you have to pay a very big price as well, right? So it is stronger and it is expensive again, right? So because of that, we don't use microwaves in our for our day-to-day activities, right? But there are certain things that we must use the microwaves, otherwise it's not going to happen, or like it's not going to happen in the fast that we want, right? So here we have to talk about the advantages of microwaves and transmissions. And before that, there are two types of microwaves. which is terrestrial, and the satellite. Terrestrial means like from one Earth station to another Earth station, the communication happens, right? So it is on the surface of Earth, right? But satellite, it's a different story, right? So this is a terrestrial sketch. This is the way that we can illustrate how the satellites are going to communicate with each other, right? So like I think you know the concept that using 3 satellites, we can cover the entire Earth or entire globe for the communication, which was a concept introduced by the Arthur C. Clarke, right? So they use microwaves to do such kind of things. And it is fast, it is expensive, remember. And the next one is the infrared. And we are using infrared in our day-to-day life without knowing that we are using the infrared. Yeah, sure, Suzu. After the class, I will bring you some plants.
Thank you.
Okay. So, I'm doing a class. Like, so no joking. Okay. Right. So, basically, in the TV remotes, it's the infrared that we are using. Right. So, like in day-to-day life, for lots of remote control things are familiar with or like are embedded with this infrared communication, right? So infrared is famous to do the short distance communication, right? And it does not mean we can't do a long distance communication as well. It is used for those things as well, but it's famous to do the short distance communication. And again, the infrared has this quality of bounce back on a surface, right? So if you can do, or if you can experience this bouncing back with your TV remote as well, right? So you get the TV remote and you direct the TV remote to the opposite side of the TV, or like the opposite direction. And you need to have an obstacle like a wall or something at your backside, like facing the television, right? So if you point your remote to the wall, which is at the back of yours, TV is still going to work, because the signal goes and hit on the wall and bounce back towards the TV, right? You can try it out and see whether it is working or not. And remember, it's not going to go through an obstacle, people. It's going to bounce back, right? So that is the nature of the infrared. So in most of the remote devices, we use that particular signal to do the communication. And the final one is the laser, right? So we use laser to do the communication, and it is again a rare one and an expensive one, right? Because why I'm saying it is rare, it is rarely used, is because to do the laser communication, we should have the line of sight, right? Because it is, again, we are dealing with the light. So if you got any obstacles in between, the light beam will be like disturbed, right? Or it will be cut down from that obstacle. It won't go through, because light is not going to go through the what we call the some particular objects, right? Through the glass or like through the glass and all these things, they are going to go. But like a wall, it's going to cut down the laser beam, right? So they need specific senders and transmitting devices as well, which again going to cost you. And again, you need a line of sight as well. But if you got all these things, it's a very speedy transmission mode, because we are communicating with the help of the light, right? So this particular diagram indicates how this is going to happen, right? So network traffic converted into a pulse of invisible light representing ones and zeros. So then the transmitter projects the carefully aimed light pulse into the air. A receiver at the other end, the link collectors the light using the lens or mirrors, right? So if you want, you can reverse direct it and do a duplex communication, right? And then whatever being received will be used. Yeah, so with that, the properties, the types of the guided media and the unguided media are done. So is it clear, everyone? Okay. So far we have learned what are the components of the communication, what are the signal types, and what are the properties of the analog signal, and what are the ways that we can use, like what are the medias that we can use to do the communication. Next, we are going to learn about some properties of the signal. So latency and bandwidth, right? So latency, as it says, network latency is an expression of how much time it takes for a unit of data to travel from one point to another, right? So it is measured by milliseconds, and it says like how much of time you are going to take to travel from one point to another, right? That depends on the communication media that we are going to use, right? Because you know, like now you know, some communication media will help you to do a speedy transmission, some will do a slower transmission comparatively. So when it comes to the latency, we always check the latency regarding a particular connection, right? So if the latency is less, that means the communication is a better one. If the latency is higher, that means it's a slower connection, right? And the bandwidth is defined is a range of frequencies and measured in hertz. All right, we know about the frequency, right? But when it comes to the bandwidth, it gives you a range of frequencies, right? And it usually going to talk as like from hertz in very much only like per second, right? So if you are talking about an internet connection, you always talking about how the speed is. So the speed means we are talking about the bandwidth. It comes with Mbps nowadays, megabits per second, megabytes per second, right? And there are some advanced technologies which measure it from the gigabytes per second, right? So with that unit, it says how speed your communication is, right? So latency and bandwidth, remember. Right now, in this picture, which is given to you, is illustrate the bandwidth and the latency. And you can see bandwidth is measured with Mbps, megabytes per second, and the latency is indicated by milliseconds. And latency depends on the communication media that we got. So we got Wi-Fi, we got a cable, we got internet service provider, and some medias in between. So now this, if you take this ISP component, they have a greater amplitude or the greater size. But since the cable has the minimum width, the communication happens according to that width, or like that, the capability of the cable, right? So even though you are using a very high-speed cables at your house, if the internet connection is slower than your cable, so you are still receiving a slower connection, right? Ogolange ගෙදර fiber totally fiber communication එකක් තිබ්බට පාරේ ඉඳලා එන connection එක එන්නේ coaxial cable එකක නම් coaxial cable එකේ එන speed එකට තමයි fiber optic එකේ යන්නේ. මොකද coaxial එකේ ගේන්න පුළුවන් ප්‍රමාණය විතරනේ ඒකේ අරගෙන එන්නේ. Right? So that's the reason. And actually this attenuation, distortion and the noise, we talk them here in this syllabus, they are mentioning them as the properties of the signal, but this attenuation, distortion and the noise are actually some impairments that we can find through a signal. Now attenuation means අපි ඔබ සිංහලෙන් කියනවා වැහැරෙනවා කියලා, කෙට්ටු වෙනවා කියලා. Right? So attenuation gives the same idea. So when you are generating a particular signal, the source contains the highest strength of the signal. Right? As a simple example, in a classroom, the students who are in the front row will be able to hear clearly what the teacher says. On the back rows, they will hear something less or something lower than the front row people. Right? It is because when the words are going out from the teacher's mouth, it has the highest strength, and it goes when it spreads on a distance, the strength of that wave or the strength of that signal is going to get lower. That is what you call attenuation, right? So the strength of a signal will be attenuated along the distance. So to avoid this, we use a particular device called repeaters, right? Or the amplifiers, which helps to amplify the signal to the original strength, right? But there are some problems when they are amplifying the attenuate signal. Sometimes that signal can contain some particular noise originally. When you are amplifying, that noise is also amplified, right? Right? But that of course only for the analog signals. With the digital signals, nothing like that is going to happen. Right? So the amplifiers are there to amplify the attenuated signal to its original position. And distortion means like mixing up the signals due to their speed. Right? Now that this is something very similar to a race that you are going to do in your sport meet, right? So the starting point of the race is equal to everyone. So when the game starts, when the race starts, the one who has the highest speed will win the race, right? So likewise, when it comes to the audio waves, there are places where the audio waves get together and create one particular signal. And that audio waves are having different types of signals which has different frequencies. So lower frequency people will go slowly. Higher frequency people will run in a fast manner, right? So the way they are receiving at the receiver end is different, right? That is what I have illustrated from these two diagrams. This side, the left side, is describing the starting point. and the receiving end, they are receiving in different time frames due to their the propagation speed, which will cause a different signal to be received at the receiver's end. Right? So as a solution for this, they are using a particular mechanism of mixing up these things through some amplitude techniques. Later we are going to learn like frequency amplitude, phase amplitude, right? And I'm sorry, not the amplitude, the modulation techniques, right? So a low strength signal can also be sent in a speedy manner to the receiving end with the modulation techniques. Right, and finally, I'm going to talk about the noise. Now, noise is something which is being taken from the outside of the signal. Right? It's not something that happens due to the signal strength or anything. It's something that is mixing up beyond the signal or from the environment of the signal. Right? So because of that, the signal is going to be changed. Right? ගොඩක් වෙලාට ටෙලිෆෝන් කන්වර්සේෂන්ස් වල සමහර වෙලාවට වෙනවා. දැන් නම් වෙනවා ගොඩක් අඩු. ඉස්සර සාමාන්‍යයෙන් අපි කතා කර ඉන්නකොට cross talks ඇහෙනවා අපිට. නැත්නම් hums ඇහෙනවා. Right? ඒ කියන්නේ noises එනවා කියන්නේ. So these noises can be categorized into many different categories. Here we have gave you some, which is thermal noise, intermediation noise, crosstalks, impulse noise, kind of thing. So thermal noise happens due to the thermal tension of electrons in a conductor. Then signal එකක් ගලන් යනවා කියලා කියන්නේ අපේ කම්බියේ තියෙන ඉලෙක්ට්‍රෝන ටික ගැහෙන්න පටන් ගන්න එක තමයි. right? එතකොට මේ එක ළඟ එක තියෙන ඉලෙක්ට්‍රෝන්ස් වලින් එකකින් එකට එයාගේ ගැස්සෙන එක transmit වෙනවා. Right? So that's what we call thermal the tension of the electrons. So due to their tension, it generates a heat. That heat can generate a noise. That is what we call thermal noise. And intermediation noise, as it says, it produced when there is some non-linearity in the transmitter, receiver, or intervening transmission system. Right? So ඒගොල්ලන්ගේ අර එක පෙළට තියෙනවා කියන එක නැත්නම් linearity කියලා අපි කියනවා. So when it is not set together, that is going to give you some intermediation noise. Crosstalks, it's kind of an unwanted coupling between signal paths. Like when a signal is transmitted from one end to another, some other signal is disturbing that. Crosstalks. Impulse noise is there happening due to the environment changes like lightning and all these things, right? So it's not very much effects on the analog data, but mostly on the digital data, impulse noise effects on. Right? So yeah, so that is the things that we have to talk about regarding the signal properties. Okay, so today I'm going to end the session from here, people, since we have discussed many different things. Next week, we are going to talk about these modulation techniques, right? So be prepare, people. By next week, we will be able to draw some diagrams regarding these encoding schemes, right? So get ready, as well as error controlling techniques, right? So I'll discuss the things by next week. So I'm going to stop it right over here only for today. People, next week we are going to have a holiday, right? No, neither next week, neither the week after, people. Not the Christmas day, not the 1st of Jan, we are going to have the class, right? We are going to have the classes on 7th of Jan, right? The 2-week vacation. That is why I told you to pay, do the half payment for this month, right? So we'll meet on 7th of Jan. And by then, if we could have the physical classes, we'll discuss it and start the class. Otherwise, we'll see what is going to happen with the situation, right? So for everyone, for the people who have the Christmas, Merry Christmas, people. And for everyone, have a very happy New Year. I'll meet you after a year then, right? We are going to meet on 2022. Right, so thank you very much, everyone. I'll see you on January, right? All right, people. Thank you very much.